A right triangle is a triangle that has a 90-degree angle in it. And the side that's opposite the 90-degree angle we call the hypotenuse. The two other sides, the two sides that are adjacent to the 90-degree angle, we call legs. This particular illustration, we have a vertical leg and a horizontal leg, but they don't need to be vertical or horizontal. We just call them legs in general. So we have a right angle, we have a hypotenuse over here, and we have the two legs of the right triangle. We're going to be using that vocabulary pretty extensively. Also, the Pythagorean theorem says that if we have A and B, if those are the lengths of the legs, and C is the length of the hypotenuse, then this formula is true with a right triangle. A squared plus B squared equals C squared. So, for instance, in this example, if I said we had a triangle with a 20-inch side or 20-inch leg and a 21-inch leg, and we're trying to find the length of the hypotenuse, then I could say, well, x squared is equal to 20 squared plus 21 squared. And that means that x should be the square root of 20 squared plus 21 squared. And that's relatively simple. That's something I can ask my calculator to do. I get square root of parentheses 20 squared plus 21 squared. And that gives me, it looks like 29. So, and that actually came out exact. Yeah, it did. Okay. So the side of this right triangle is 29 inches. If we're given something like this, you can see my right angle is here. We're actually given the hypotenuse. I'm going to call this y since I just used x in the previous problem. We can still say the Pythagorean theorem is valid though, but notice when I use it, I would say 6.21 squared plus y squared equals 6.29 squared. So the where the y is not alone, so I can't just take the square root of things at this point. What I need to do is I first need to get rid of this 6.21 squared. I need to get that onto the other side of the equation. So when I subtract 6.21 squared from each side, I get y squared equals 6.29 squared minus 6.21 squared. I'm intentionally not actually squaring these numbers because that doesn't really add anything to this particular discussion, and they're they just get a little bit more ugly. So I'm just referring to this number as 6.29 squared, this number as 6.21 squared. One thing you do not want to do is you do not want to think that you can do 6.29 minus 6.21 and just square that result. That would mess up your order of operations, and that doesn't work. So what we'd want to do now is we'd want to say take the square root of 6.29 squared minus 6.21 squared, and that'll give us the length of y. So I'll plug that into the calculator here. Parentheses 6.29 squared minus 6.21 squared. Close my parentheses, and this gives me a length of 1. Y equals 1. It's not always going to come out as a nice number like this. This is just a few specific examples.